This is the review for Test 4, Part 3. Number 11 is asking us to solve log equations. And in most cases, if we're going to solve this, we need to get things shifted back to exponential form. So 36 raised to the 1/2 power equals x. Two ways to go here. One is to use your calculator and just enter this as 36 to the, but you need parentheses around the 1/2. And that equals 6. The other is to think about what the 1/2 power means. It means square root. So this is the square root of 36 equals x, and x is 6. It's a natural log equation, and before we deal with the natural log, we need to have the natural log part of the equation isolated. So since this is 6 times the natural log, we will divide both sides by 6. So now this says natural log of 2x equals 3. And the way I deal with this is natural log. The opposite of natural log is raising e to the power. So I'm just going to slip in a little e to the. As long as I do it on both sides, it's okay. And the reason this is a nice thing to do is e to the ln is going to cancel out, and all you get is 2x. E to the third is something that you can do on your calculator, and it is about 20.086. Divide both sides by 2, and we end up with 10.043. Another way to do this is if you've got log base e of 2x equals 3. Remember, ln means log base e. So change this to the exponential form like we did over here. This gives us e to the third equals 2x, which is the same thing I had right here. E to the third equals the 2x. All right, these are a little more complicated coming up, and that is you're going to have to use your properties and get this condensed. Before you can get out of logarithm form, everything's got to be condensed on each side. Well, log of something plus log of something becomes the log of the product. So this is log base 2 of x times x minus 7. This is a logarithm equation. Change it to exponential form. So this is 2 to the third equals, I'm going to go ahead and distribute this, x squared minus 7x. 2 to the third is 8. So now this is a plain old quadratic equation. All the logarithm stuff is gone. To solve a quadratic equation, you have choices of factoring or the quadratic formula. Either way, you want everything on one side in descending order. I'm going to factor this because that's easier. Factors is x minus 8 times x plus 1, which gives me these two supposed solutions. The reason I say supposed is that you've got to check when you're dealing with a logarithm equation. Remember, you cannot take the log of 0, you cannot take the log of a negative number. So if you put 8 in here, are you taking the log of 0 or the log of a negative number? No. Log base 2 of 8, that's okay. Log base 2 of 8 minus 7, that's okay. But watch what happens if I put the negative 1 in here, for here or here. I'm taking the log of a negative, which I cannot do. That means a negative 1 has to get tossed out, and we only have one solution. Similar problem, just a different property. This is log of something minus log of something. So this becomes a quotient. Log of x over x minus 3 equals 1. Now remember, log is log base 10. So when you convert this to exponential form, it is 10 to the first equals x over x minus 3. I would put a bottom on that and just cross multiply. Of course, 10 to the first is just 10, so I can pretend that wasn't there. Cross multiply, I get 10x minus 30 equals x. Simple equation to solve, subtract 10x from both sides. So I have negative 30 equals negative 9x. Divide both sides by negative 9 and simplify that out to 10 thirds, which if you plug it back in here, log of 10 thirds is okay. And if I do 10 thirds minus 3 inside the parentheses, I'm still left with a positive number, so I'm okay. Notice here we're going to have to use the properties, but also on this side we have log of something. So when we get to the end, it's going to be a little bit different. But on the left side, this will be log of x times x minus 1 equals log of 30. This is pretty nice. If you have log written one time on each side like we have right here, we can just drop that off. So all we have is x times x minus 1 equals 30. So when you have log written one time on both sides, it's an easier problem to solve. Distribute the x is x squared minus x equals 30. It is a quadratic equation, so I've got to have everything on one side equal to 0. This factors is x minus 6, x plus 5. And keep in mind, at this point, I could use the quadratic formula. It's just that factoring is faster. If you don't factor very well, the quadratic formula will work. It just takes more time. So we have these supposed solutions, 6 and negative 5. So if we plug 6 back into the original equation, that says log of 6, which is legal. 6 minus 1 is 5, so I would be taking log of 5, which is legal. So the 6 is okay. But if I put negative 5 here or here, I'm taking the log of a negative. So the negative 5 gets thrown out. My only answer is 6. Does this mean every time you solve a log equation that you're going to have to throw out one answer? No. Sometimes you keep both answers. Sometimes you throw out both answers. So it just depends on the numbers. Same properties hold true when we're dealing with natural log. This is natural log of something plus. So my property is going to tell me that this is going to be x minus 4 times x plus 1. And the right side just stays as is. Over here, I'm going to have to FOIL this out. And if you FOIL and combine, you're looking at x squared minus 3x minus 4 equals the same thing right here. So we have ln on both sides. So I can drop both those ln's, and I'm just dealing with x squared minus 3x minus 4 equals x minus 8. We will need to get everything over on one side equal to 0. To do that, we're subtracting x, adding 8, and this will give us x squared minus 4x plus 4 equals 0. It factors as x minus 2 times x minus 2, which gives me solution of 2. But if you plug 2 back in here, you're taking the natural log of a negative, which you can't do. So that one solution gets thrown out, and our answer is either that, or you can write no solution. Couple things before we go to the next set of problems. Number one is, because these are all plain old log or natural log, you can use your calculator to check these straight out. You can type in, let's say right here, you can just type in log, let's say we're checking 6, log is 6, put it in parentheses, plus log, parentheses 6 minus 1, type that in the calculator and see whatever decimal you get, and then over on the other side, you're going to then type in log of 30, and those two values are going to be the same. Because it's log, which is log base 10, which is the calculator button, or because it's natural log, you can let the calculator do the check for you rather than trying to do stuff in your head. Second thing to point out is that there is a big, big difference between D and E, or D and F, and that is this. When you condense over here, you have log base 10 of x over x minus 3 equals 1. You only have the log word written one time on one side. And the only way to undo that is to switch it to exponential form, which is what I did here. This is different. Once we condense this, we had the log word written one time on the left side and one time written on the right side. That's the only time you are allowed to drop the word log. You cannot look at this problem and go, oh, let's just get rid of those log words. You can't do it until you have each side condensed as far as possible, and you have log written one time on each side. We have a couple word problems coming here. This says $1,500 is invested in an account which earns 5% per year compounded continuously. Compounded continuously tells me that we're talking about the PERT formula. And then it eventually asks me how long will it take the investment to accumulate to $5,000. That means we're looking for T. This is not the exact problems we did in the very beginning of this review. This you were trying to solve for T. Those you were looking for A. So let's stuff in. $1,500 is your P. E is E. The rate is 5%, which is 0.05 times T. And we want to know how long it's going to take it to reach $5,000. So we need to solve this for T. We have to isolate that exponential part. So the first thing we'll do is divide both sides by 1,500. So now this side says e to the 0.05 t, and 5,000 divided by 1,500 is approximately 3.33. Now I'm writing down 3.33. What you need to do is leave this whole number on your calculator. It's actually 3.3 repeating. Leave the whole number on the calculator. Now to undo that exponential equation, we will take the natural log of both sides. On the right side, we know that that's going to cancel, and all we get is 0.05t. Remember, you've got this 3.333, etc. on your calculator, so now do the natural log of that, which is approximately 1.204. I'm not just typing in ln of 3.33. I would actually do ln of second answer, and that means the calculator is going back and is accessing the whole number. So right now I've written 1.204. What would be on your calculator is a much bigger number. Leave it there. To solve this, I would need to divide by 0.05. So you're taking the big number that's on your calculator, divide by 0.05, and it comes out about 24.08 years. Keeping as many digits as you can as you do the problem will make your answer more accurate. Similar problem, but this time it says it is compounded monthly. Compounded monthly is our longer formula, A equals P times 1 plus R over N to the NT. So let's stuff in. 2,200 is invested. It earns 3%, so that's 0.03. Be sure you get the decimal in the right place. Compounded monthly, that means N is 12, parentheses, raised to the 12t. We want it to accumulate to $4,000. We'll do some similar steps to the last problem. First thing is divide both sides by 2,200, and that's about 1.818. Inside the parentheses comes out to be 1.0025 to the 12t. To undo this exponential, we need to take the natural log of both sides. So I'm just still keeping this as the ln of 8.18. Over here, the benefit of taking the natural log of this is this coefficient gets to come down here, or this power gets to come down here and become a coefficient. So we don't have an exponential equation anymore. This is something very solvable. At this point, I will divide both sides by the natural log of 1.0025, natural log of 1.0025. Remember, you need parentheses around these. And then, I could do this arithmetic on the calculator, but instead, of course, this is just canceled out, I will divide right now both sides by 12. So you have this big complex fraction over here on the right side, and that's exactly what you can enter on the graphing calculator. ln parentheses 1.818, close your parentheses, divided by ln 1.0025 divided by 12, and this works out to be 19.95 years.